In this video, we're going to talk about describing different types of data. So first, a little bit of vocabulary. Statistics is just any time we're trying to learn from data. We have two kinds. We have descriptive statistics, which is the science of summarizing or describing the data, either with numbers or graphs. Then we have inferential statistics, which is the science of trying to use our data from a sample to try and infer or learn about the population. So our population is the set of all people, items, events, objects, etc. that are of interest to us. So for example, that could be everyone in the US, or every Honda car built in 2010, every English major at 4 universities, etc. But then we have a sample, which is a smaller part of our population that we actually collect the data on. So for example, instead of looking at everyone in the US, we could look at, say, every 1,000th person in the US, which would make it a lot smaller. Or instead of every Honda car, we could look at maybe every 500th car to come out of the Honda factory, or just 300 English majors. So you can see we take a much smaller sample, so we don't have to look at the entire population. Now, why would you want to look at just a sample and not a population? Well, our population is usually too big, so it would be too time consuming and too expensive to look at the entire population. So instead, we'll just take a small sample. So some more vocabulary. We have cases or observational units depending on which book you're reading. So a case would be each of the objects in the study that we're going to describe with data. So like each of the individual people in the study would be a case, or each of the cars or each of the English majors. Those would each be the cases, the individual person or object. A variable is some kind of characteristic that we want to measure. So like the height of the people, or color of the cars, or the time it takes you to graduate. Now we can divide variables into two groups. We have categorical and numerical. Categorical is a variable that places a case into one of several groups or categories. So like a person's gender is either male or female. So notice this isn't anything with numbers, it's more just categories. And then you have make of an automobile, Honda, Ford, Dodge, etc. Now numerical variables are variables that take values for which arithmetic operations like adding or averaging make sense. Other books will call it a quantitative variable. So numerical variable, something with numbers, could be like your average starting salary, or a gasoline mileage, a height. Those are all things that deal with numbers. So let's practice here. Are the following variables categorical or numerical? The amount of carbon dioxide produced by a car. I'm not actually someone that studies this, but I would assume you would measure it in like parts per million or something. So if you're measuring parts per million, then that would be numerical. Color of a car, well, that's definitely going to be blue, green, etc. That would be categorical. Breed of a horse, that seems like you would have names or words to describe that, so it would be categorical. Length of time to graduate from college, let's see, that would be the number of years, so numerical. Social security number, this one's kind of a trick because it is numbers, but the numbers are just a symbol. So the best description for this is that it's a label. So it's not really a variable because it doesn't actually tell you anything about the person. It's just a way to identify the person. Not really a label. The length of your favorite song, that would be numerical because you could keep track in seconds or minutes. But the artist of your favorite song, you can't describe that with numbers, so that would be categorical. In our next example, we want to know the final grades or percentage of all students in the U.S. in introductory stats classes. So what would be your population? Remember, the population is everything of interest. So this would be all students in U.S. intro stats classes. What would be a possible sample? Well, there are many choices for this one. You could look at maybe 50 random students from each university, or maybe 10 students from each university, or maybe you could look at 100 students from 10 different randomly chosen universities, etc. You can just somehow make this a smaller sample. So I'm going to say 50 random students from 100 random universities. That would actually still be quite a big sample. Oh wait, students in the random universities in intro stats classes. What would be the cases or observational units? That would be each individual student. And what is the variable? The variable would be the final grades. That's what you want to know about. And would that variable be numerical or categorical? Well, this depends. Oh, no, it doesn't. I said up above. It says, I told you I want to know the final grades as a percentage. So if we're talking about the percentage, then that would be numerical. If I'd taken a letter grade like A, B, C, D, then that would be categorical. But since I said percentage, that is numbers. You can classify this even further. So this is a handy little chart. So all variables are either categorical or numerical. Now, categorical variables can be split into ordinal and nominal. This isn't something we'll really stress on the categorical. It won't affect us as much. The numerical ones, though, I do want you to know that distinction. But for categorical, we have ordinal. So there's some kind of natural ordering to the categories, such as like good, better, best. So that's something where you do have a natural order. Or short, medium, tall. Okay, so again, tall is going to be higher than short. Now, nominal variables means there's no natural order. So like red, blue, black, there's just no natural order. There's not something that's bigger, smaller, etc. But numerical can be broken down into discrete and continuous, and this is very important because this affects a lot of what we're going to do. So discrete variables, a discrete variable is one that can only take specific values. So I can tell you in advance what all the possible values are. A continuous variable is something that can take any value in an interval of numbers. So again here, specific values, any value. So for example, the gas mileage of a randomly selected mid-sized car will be X. Even though we might round the gas mileage to the nearest 1/10 of a mile per gallon to actually write it down, the true possible values for the gas mileage could be like 26 or 26.1, 26.05, 26.005, etc. You can see I can be any possible number in this interval, and that's what makes it continuous. So in this example, let's state whether each one is going to be continuous or discrete. Sometimes it helps if we list all of the possible values of X. So the temperature of a cup of hot chocolate served in a McDonald's restaurant. Temperature could be like any value between, I don't know what your coldest would be, so I'm just going to make it up, maybe like 30 degrees and 300 degrees. Okay, but the important thing is it could be like any value in there. So that would make it continuous. Okay, now the number of 4 patients taking a new antibiotic who experienced gastrointestinal distress as a side effect. Notice this, the number of 4 patients. That means your possible values are going to be X equals 0, 1, 2, 3, or 4. So I can tell you in advance that those are your only possible values. That means it is going to be discrete. Anytime you see that keyword, the number, so number is always going to tell you it's going to be discrete. Now let's see, the score on a test that's graded in 0.25 increments. Well, if you're graded in 0.25 increments, your score could be 0, 0.25, 0.5, 0.75, 1, 1.25, etc. So I can tell you in advance what the possible scores are. That makes it discrete. Or it can only be those specific values. Okay, number 4, the weight of strawberry preserves dispensed by an automatic filling machine into a 16-ounce jar. So this seems like it could be any value around 16 ounces. So I would say continuous. Let's see, the age of a student in this class. Let's assume that you have to be 18 and no one lives past 100. Let's see, so if you think about this, people usually respond in a discrete manner. So you usually say, I'm 18, 19, 20. But how old are you really? So you're not just 30, you're going to be 30 years, 5 months, 2 days, 3 minutes, 2 seconds, 5 microseconds, etc. So this one is something that is theoretically continuous because you can be any age between 18 and 100. Okay. Sometimes though, even though we usually round to the nearest whole number. Okay, so if it could theoretically be continuous, we'll always put continuous. You'll see at this point that we're at a now you try section. So at this point, pause the video, try this on your own, check the answers in the back of your course reader, and if you have any questions, this is a good time to post them in the discussion board.